Dear learners, in this video we are going to discuss about the unification process. Unification in artificial intelligence is said to be a process in logic-based systems that enables the matching of two logical expressions by finding the appropriate substitutions for the variables present in it. Unification is used to make two different logical expressions to be identical by finding a suitable set of variable bindings. This process is essential in the areas such as expert systems, theorem proving, and natural language processing. It is a key component in all the first order inference algorithms. We discuss an example for unification. Let us consider two logical expressions E1 and E2. Two expressions in the predicate logic. So expression 1 is predicate of x comma a and expression 2 is represented as predicate of b comma y, that is p of x comma a and p of b comma y. Now these two expressions are not similar, right? So by using the process of unification, what we are going to do is we are going to unify these two expressions by finding a substitution theta which makes this expression E1 and E2 to be identical. That is what we are going to do now. Here, these are the considered expressions, right? P of x comma a and p of b comma y. Both the expressions have the same predicate. Therefore, we can proceed to unify their arguments present. Arguments are x comma a and b comma y. So the first step, let us unify the first argument. The first argument of E1 is x. E1, the first argument is x, and E2's first argument is b. Now, how can we make these two expressions identical? Is by substituting x as b. Okay, so that is what we are going to do here. As the first argument of E1 is x, second argument of E2 is b. So we are going to make these two expressions equal, means we want to find the common substitution. Okay, so we need to find the substitution that makes x equal to b. So thus the substitution here is decided as x is substituted as b. So that is what we have written as x slash b. And the second step, the expression involves two arguments, right? So the first, we discussed about the unification of the first argument. The second thing we have to consider is unification of second argument. That is what we are going to do now. Consider the second argument in E1. The second argument in E1 is a and the second argument in E2 is y. Now we have to find the substitution such that these two arguments are identical. So what can we do is we need to find a substitution that makes the variable y to be equal to a. So therefore, the substitution here is written as y slash a, that is y is substituted as a. Now, both the expressions are identical. Here we have find the combined substitution for these two variables, that is the argument, that is what we have written here. Okay, so the substitution here is written as theta. Okay, so theta is equal to x is substituted as b and y is substituted as a. Now, both the expressions now seem to be identical after applying the substitution that we have found out during the unification process. So the actual arguments of E1 is p of x comma a. X is substituted value is b. So instead of x, I can put b. Similarly, for E2, y is substituted as a. So when y is substituted as a, expression 2, logical expression 2 will also become p of b comma a. So what we can observe here is after applying the proper substitution, we can make the two logical expressions to be equivalent, or we can say to be identical. Now after applying the substitution, we can definitely observe that the logical expression E1 and E2 which is P of B comma A and P of B comma A is identical. This is what the purpose of unification is. Unification plays a very crucial role in various AI applications, particularly in automated reasoning, logic programming, as well as in knowledge representation.